philosophy of sexual reproduction. So here you are looking at something glorious. Here you are looking at the start of a life of an animal. This is the egg, and this is the sperm. One of them will be lucky enough to fertilize the egg, and then they are going to fuse, their nuclei will fuse, it will form a zygote, which is the fertilized egg, which is going to be a new life, a new soul, a new animal. Okay. The story I want to tell is mostly about the cycle of these things, because there's this diploid organism, and then it has meiosis. Of course, this organism is diploid. After meiosis, it becomes haploid, and then it becomes diploid again. Of course, this man cannot reproduce itself, so it needs the help of somebody else, another organism, which has another haploid gamete, maybe coming from a lady, most possibly coming from a lady. Two males cannot reproduce yet by themselves. Okay, this time it's going to be female. And we know that the process which creates this haploid cell from diploid cell is called meiosis. And this process which creates diploid from haploid is called fertilization. So in a way, our life cycle between fertilization and meiosis. So we are running between these two, meiosis and fertilization, meiosis and fertilization. So this is the normal way of things. So think about this guy. How long do you think he's going to survive? Maybe 20 years, maybe 50, maybe 100 years. Let's say he's going to survive 70 years. And think about the sperm. How long the sperm will survive? 3 days max. So although our life shuttles between two type of cells, this type of cells, which are the gametes, they're going to survive only shortly. So we are going to spend majority of our life as diploid in this form. And only the minority of our time here as the haploid self. Well, this comes to very normal to us. This sounds very normal, but it is not that normal, because there are other kind of life forms in the world that they spend majority of their time as haploid case, and they only become diploid only rarely when when the environment is harsh, when they need genetic diversity, and right after they have this diploid case, they have another meiosis and come back to this haploid case immediately. So they spend majority of their time here as a germ cell. So, or I shouldn't say germ cell, but as a haploid cell. So diploid is strange for them. So if you check the organisms in the world, you're going to see very strange things. And the human state is not the only normal thing. There are many normals all along the organisms. So this is what happens in the animals. The mother has a couple of cells, let's say the father has a couple of cells. They are similar, and when they go under meiosis, it halves. And then because they are coming together, it doubles again. So 1/2, 1 double. It has the same amount of DNA with the parent, but the diversity increase. Now it has different chromosomes, maybe different alleles, new alleles, which doesn't exist in mother or father, which is also very normal. This way, the sexual reproduction increases the genetic diversity, and well, this, or maybe I should come here. Okay, formation of the germline cells. We have never seen embryology with you. We have never seen development, but after the zygote comes to life, this is the zygote. After this cell is fertilized, it is going to make a ball, and in this little ball all the cells are equal. Now, from these equal cells, some of them are going to be separated very early stage. These are the germline cells. Okay, both in males and females, they are put aside. So they are well taken care of. They are separate from the rest of the cells. They should be taken care of really good, because if these cells are damaged, this organism will develop, but it's not going to have children, because the children will come from these cells, which are the germline cells. These are the cells that go under meiosis. So rest of the body, these somatic cells, they have no capacity of meiosis. They can only and only go under mitosis. Only the germline cells have the capacity to go under meiosis. So in a way, these germline cells are immortal, because they're going to create the again sperm, which is going to fertilize in the next embryo. Again, they are going to make the germline cells from generation to generation. They are going to spread. Of course, in each case, it's going to reshuffle and allele change. But all in all, as the organisms continue to reproduce, these cells are going to survive. On the other hand, the somatic cells here, they are die. The somatic cells, although they have loss of mitosis at one point, they doomed to die. Okay. So this is why we say the somatic cells, they're going to die. Their fate is to die, while these germline cells are immortal. Okay. So even imagine that there is a mutation here. A new mutation arose here in the somatic cells. It's a spontaneous mutation, and it doesn't exist in the germline cell, and let's say it gives a superpower. So this organism is going to have superpower. Let's say it's going to be Superman. But only and only in the somatic cells. In the germline cells, let's say here, that mutation will not exist. So as this man dies, the mutation will also die with it. It's not going to be transmitted. So the only thing transmitted is the mutations here in the germline cells. So in a way, in this man's body, the germline cells are the only things that is going to be transmitted to the next generation. So one view says that we are carriers, we are all carriers of our germline cells. Or to make it in a slug language, we are bags, we are big clever bags of our sperms and eggs. And our only purpose, the unique purpose, is to propagate our germline cells to the following generations. So personally, I find it a bit oversimplistic, especially in a society, in a kind of animal like human, which lives in social groups and where each individual can contribute to society in different ways. This is kind of being too simplistic. I don't really follow the selfish gene idea, but there are opponents, proponents of this hypothesis. It depends on you. You can read the selfish gene hypothesis. Also, you can read the Red Queen. I strongly suggest, if you want to understand everything about sex and why do we have sex at all. Okay, it gives the diversity. They are kind of immortal, but at the end, it is quite inefficient. This man is going to grow up, and then we'll have the testicles mature, and then we'll have sperm, and then he's going to find the girl who is going to mate with her, and then they are going to mate and have child. This is a very long process. So if it is so long and inefficient, why do the organisms have sex at all? Well, obviously, it generates the genetic diversity. The second thing is, in mammals, not every man will manage to mate because each organism is a combination of alleles. Each time there is a meiosis, you're actually gambling. It's like rolling a dice. So when you roll the dice, when you do the combination of the alleles, there are always good combinations and bad combinations. So meiosis and fertilization, it will create good combinations as well as bad combinations with equal numbers. And these bad combinations, do you think they will propagate in the next generation? Do you think this will go on? Well, maybe yes, maybe no, maybe they are going to propagate less. Maybe these combinations, who is very healthy and very strong and very clever or good hunter or handsome or whatever, they're going to have more children, supposedly, while these bad combinations, they're going to have less children. So, in a way, we say that, I apologize from the males are kind of filtering device of the sexual reproduction system. Because if a bad combination happens in a female, it's easier for the females to find the mate because they are the one who is going to carry the child. So as long as they can carry their child and take good care of them, they have a chance. They still stand a chance. But for the males, it is more difficult. So the bad alleles in the males, they will be cleaned out from the population. Okay, this is a way of adaptation. Okay, and then we start with the molecular